So we're going to take a look at this particular problem. A pharmacist receives a shipment of 17 bottles of a drug and has 4 of the bottles tested. If 6 of the 17 bottles are contaminated, what's the probability that more than one of the tested bottles is contaminated? So I'll jump straight to the point. This is a hypergeometric problem of a discrete probability distribution. Now the issue is, how do you know it's a hypergeometric? You have a large group of elements. In this case, it's 17 bottles. That represents the total population of bottles that you have. And of that population, you have a smaller subset that's going to be sampled or tested or selected. So those are the types of words you look for to identify the sample size. In this case, it's 4. But what's key about hypergeometric problems is they also tell you the number of successes that exist within the population. So in this case, they tell you that, or they have you assume, if 6 of the 17 bottles are contaminated, and then they move on to ask the question. So contamination is, in this case, the success that we're looking for. So out of the 4 bottles that are sampled, we want to know what's the probability that more than one of them, in other words, 2, 3, or 4, are contaminated. So using the toolkit, the Hypergeometric tab takes you to this sheet. The number of possible successes, in this case, R is 6. Population size is 17, and the sample size is 4. But what we want to know is, what's the probability of having more than one? So X in this case at 1, probability of having exactly 1 would be 0.14597. That's not the number we're looking for. The second column gives you the cumulative probability of having less than or equal to X. So the probability of having less than or equal to 1 would be 0.55462. What we want to know, though, is the probability of having more than 1. So if we take this 0.55462, which is less than or equal to 1, if we subtract that from 1, then we have a probability of 0.44538, or to 4 decimal places, 0.4454. So even if you didn't have this 1 minus cumulative column in your toolkit, the second column of the cumulative probability of less than or equal to X, you would know to subtract that from 1 to get the probability of greater than X, or greater than 1.